Now that we know how to multiply and divide monomials, we're going to apply this concept to working with polynomials that are being multiplied and divided by a monomial. So we're going to be using the distributive property and exponent rules to multiply a monomial and a polynomial. Let's look at the following example. We're going to multiply 3x cubed, which is a monomial, times the following polynomial. Like with addition, we can set this up vertically or horizontally. We're going to start vertically here. So I have my multiplication problem, and I just used a dot to show multiplication instead of an x, since we are working with variables. We don't want to confuse a multiplication symbol with a variable. So I'm just going to multiply each term in my polynomial times the monomial. So I'm going to multiply 15 times 3x cubed, which is going to give me 45x cubed. Then I'm going to multiply 8x times 3x cubed, which gives me 24x to the fourth. Next, I'm going to multiply 6x squared times 3x cubed, which gives me 18x to the fifth. And last, I'm going to multiply 5x cubed times 3x cubed, which gives me 15x to the sixth. And then this last polynomial is the product of the monomial and the first polynomial. I could also write this horizontally and think of it as the distributive property, in which I multiply 3x cubed by every term in my polynomial, giving me the same answer I saw previously. So either approach is fine. When we divide a polynomial by a monomial, again, we are going to be working with the distributive property and exponent rules. So let's look at the example below. We have a polynomial, and it is being divided by the monomial 3x squared. Basically, we're going to divide 3x squared into every term in our polynomial. We can write this as long division, or again, we could just divide 3x squared into every term. So I'm going to show you a couple ways to write this. With long division, you can see I divide 3x squared into 15x to the fifth to get 5x cubed. I bring up my plus. I divide 3x squared into 6x to the fourth to get 2x squared. So I'm just using my exponent rules where I subtract 4 minus 2 on my x's to get 2, and then 6 divided by 3 is 2. And then 18x cubed divided by 3x squared is 6x, and 9x squared divided by 3x squared is 3. I could also write my problem this way. So this is basically the distributive property. So I'm dividing, I think of it as dividing 3x squared into each individual term, and I just wrote the answers above each individual term. So just a different way to do it. Try this first problem and then check back to see how you did. Here's my solution to this first problem. Try the second problem and let's see how you do. Here's my solution to the second problem, in which I use the distributive property. So I've demonstrated both approaches in these first two examples. So now let's move on to working with these last two problems. Go ahead and try these last two problems with division and check back to see how well you completed. In this first division problem, you may have noticed that you end up with some improper fractions. You can leave your fractions improper. You do want to simplify them, but you can leave them improper. So here's your solution to this first division problem, with one quick exception that I just caught, which would be that there is no x right here. So let's look at the second example. In the second example, again, we end up with a fraction, but you can simplify it. 4/8 equals 1/2. Now, I should have had an x, obviously, in my first term instead of an a. So hopefully you caught that.